Everyone, in this video, we're going to be looking at how to take an absolute value quadratic graph and turn it into find what the function is that models it. And so there's, as always, there's a few different ways to complete this task. The one thing I will say is that sometimes it's very dependent on the information you're given. I should say it like that. Most often, as long as we know the vertex, it's going to be much easier to work just in vertex form and solve the quadratic like we normally would, and then look to see how it's been absolute valued. Um, there usually is more than one solution that will be acceptable, and it kind of comes down to depending on whether or not you viewed the quadratic as being initially reflected and then the absolute value sign reflected it, or was positive and the absolute value sign has a negative in front of it, depending on some situations. So when you're doing these, it's possible to usually there's two different ways that these can be solved. There are two different solutions that look superficially different but still give you the same graph. It just comes down to how you view the reflections having happened. But anyways, I'm just going to solve for the quadratic and then think about how it's going to be reflected. And basically that's pretty much it. Like, these questions are fairly straightforward. So I'm going to look at this one right here. So I can see I've got an absolute value quadratic. I can see my vertex is there, and I've got a random point. So I can just solve for my a value and solve for my quadratic, ignoring the fact that it's an absolute value sign initially. And I don't have to do any fun switch arounds, because this -1, 2 is on the part of the original parabola. If it was up here somewhere, I'd have to reflect it back down to where it was before in order to do the algebra part. But because this is on the same section, it has part of the same, piecewise function part, if you can think about it like that, then I'm just going to, it's going to feel very normal to begin with. So I'm going to say a and then x plus 2 squared plus 3 is equal to y. And then I'm going to use this as my x and y here. So I'm going to say 2 is equal to a -1 plus 2 all squared plus 3. And I'm going to solve for a. So this will be 2 on 2, or 2 is equal to a on 2, 1 squared plus 3. Minus 3 from both sides will give me -1 is equal to a. So my parabola then, the original parabola before the absolute value signs, was going to be y is equal to negative x plus 2 squared plus 3. But I've got these, clearly it's been absolute valued. So, the original parabola looked like this going downwards. But because of the absolute value signs, everything got reflected up. So I'm just going to put absolute value signs literally around the entire thing like that. And that's the solution right there. I had my original parabola, I saw that it was reflected, and I put absolute value signs to denote that at this part right here, everything got reflected up. Let's come down here. So here, this is an interesting thing. This is a good example of there being, clearly I can see a couple of different ways of thinking about this. I can treat this as if it was just this parabola right here, and there just happens to be absolute value signs around it. I can also treat it like the parabola was like this, and then I put absolute value signs around it, and it got reflected up to where we see it, over there. So either one works, and that's why there's, going to be more than one solution to this particular case here. So let's rewrite this. Y is equal to a onto x plus 2 squared plus 3, and then I'm going to take this as my x and y and plug it in, and I'm going to say, what am I going to say? I'm going to say 4 is equal to a -1 plus 2 all squared plus 3. And then I'll solve for a. So I'm going to have 4 is equal to a onto 1 squared plus 3 minus 3. 1 is equal to a. So just a nice one-to-one relationship. And I probably could have seen that just by seeing, hey, they go over 1, up 1. Probably much an easier way to figure out my a. But I could literally just take this then. So y is equal to x plus 2 squared plus 3, and just plop absolute value signs around it. The other way I can think of it is to think of it, like I said, where it's the reverse of this, where the original parabola looked like this, where it was -2 comma -3, and then it opened downwards like this, and then treat it like y. So if I rewrite that, I got to be careful here. So y is equal to negative x minus, that should be -2. No, it should be +2. X plus 2 squared minus 3, and then close that. This right here, these are the same graph, just different way. Like I said, different ways of thinking about what the original parabola looked like. So that's what I mean when some of these, I believe all of them have two different ways of writing them. Let's take a look at this one. So for here, I see I know my x-intercepts. So I like that. I mean, I'll solve this one a little bit differently. I know I wrote vertex form here, but let's try something a little bit different. I can write this as y is equal to. I'm just going to write the absolute value signs for a second here. So a onto x, and then x minus 3. And now I've got to find what my a value is. So I'll plug this vertex in to find my a value. So I'm going to have 4.5 is equal to a onto 1.5, and then 1.5 minus 3. So this is 4.5 is equal to a, and then that's still 1.5, and this will be negative 1.5. So this is going to be 4.5 is equal to a onto 15 times 15 is 225. So this will just be negative 225, 2.25. When I divide that away, that's going to give me 2 actually. So 2 is equal to a, negative 2 I should say. So if I come over here and rewrite this, so y is equal to, and then absolute value signs, negative 2 onto x minus 3. And then that right there would be this graph written in factored form. You can, of course, write in vertex form. You can even expand out here. And just to be clear, I got this x and this x minus 3 by just knowing where my my x-intercepts are. So I just wrote them in factored form. And that's it. So that wraps up the first lesson here. There's this Desmos activity that's in your notes. Please click that and go through that. And we'll go through it in class the next time I see you guys.